Next is, we will discuss in detail our ring A. So, ito yung ating ring A. So, na-mention ko na kanina si C1 and si C3, essential for activity and cannot be modified, especially the amide group. Okay, so replacement of the amide with nitro or aldehyde abolishes the activity. And then monoalkylation of the amide reduces the activity. Now in C4, dimethylamino at C4, this one here, this is methyl, itong parang horn dito that represents, di ba, a methyl. So dimethylamino in C4 can be free or it can allow further N-methylamino, but you should not put larger than methyl in that part because again it will diminish activity. So more or less, ito na siya ang pinaka best na structure dapat sa C4. So ito yung pinaka the best structure for C1, C2, C3, and C4. Kaya hindi siya replaceable. If we would know that the certain carbon or certain part of your drug is replaceable for betterment or for improved activity of the drug if it has letter R. So it means to say R is ready for alkyl substitution for any addition that would enhance or upgrade the drug. So dimethylamino must have an alpha orientation and the other isomer is much less active. For ring A and ring B, this should have cis fusion with hydroxide at C12A. So we have here, this is C12, you can see the cursor, C12, and then this one is the C12A. Okay, so if you can see there is a broken line, it means to say that the hydroxide in the 3D dimension, it's under or it's situated below. So if you can recall your organic chemistry, if they are both positioned on top or at the bottom, it is called as cis configuration. So therefore, it's a cis fusion with hydroxyl functional group. So OH group at C12A must be free. So esterification abolish the activity. Now hydrophobic substitution at C5, 5A, 6, 7, 8, 9 resulted in retention and sometimes improvement in activity. So the C5, this one here, C5 in the top of the structure, C5A, 7, 8, and 9. They can be substituted. So meron tayong mga R dito nakikita. So these are the areas for substitution. Sometimes it retains the activity even though you have substituted, but sometimes it also allows improvement. Now, the presence of hydroxyl at R4 does not have important role in activity. So let's look at R4, this one here on top. So any substitution, so the presence of hydroxyl there does not give any clinical importance. So such as in the example, demiclocycline and oxytetracycline, and minocycline and doxycycline. So I will ask you later on in the activity that I have prepared. You will try to look for the structure of this for two pairs of drug and look at their R4. Now for ring B, C, and D. So modifications at C6, C7. So let's look at C6, C7, which has the R1, 2, and 3. It will modifications there makes it hydrophobic and will render the drug to be more stable or at its greatest stability. And it will increase its antibacterial property and its pharmacokinetic activity. So dehydrogenation between C5A and C11, C5A here at the back of or at the bottom, and C11 forming a double bond can markedly decrease the activity of the drug. So you will not remove the hydrogen, or you will not perform dehydrogenation, because that will affect, it will decrease the activity of the drug. And then polar substituents at C5 and C6 can markedly decrease its lipid solubility. So you will add something like polar substituents in C5 and C6, of course, that will promote polarity, hence lipid solubility will decrease. Now, with regards to ring B, C, and D, and dimethylamine at C7, this one here, C7, if you will substitute this R1 here with dimethylamine, it will increase its activity. So alkyl substitution also at C11A, here at the lower part, in the fusion part, you can see the arrow, that's the C11A. If you will add methyl, ethyl, or any alkyl at this part, it will lead to inactive compound. So if there, in other words, again, I will emphasize, if there are no R's, they're not favorable for substitution. So this one here must remain intact and constant to preserve the minimum antibacterial requirement for tetracycline. Now, with regards to chemical stability, in presence of acidic conditions, they undergo dehydration at C5 and 6. So this followed by double bond migration from C11. So this just explains why tetracycline is unstable in acid, because of the points at C5 and C6 and C11A and 12. Okay, it has hydroxyl functional groups that are readily dehydrated. Okay, dehydrated or mabilis mag-withdraw ng water because of that weak bond. And therefore, it will be rendered unstable in the presence of acid. Now let's have basic instability. So basis promotes a reaction between C6 and C11, almost the same with our acid instability. So the inactive isotetracycline, so if our basis promotes a reaction between C6 and C11, it forms the inactive form of our tetracycline called isotetracycline with a lactone ring. So if my action doon sa C6 and C11, it will really render our tetracycline inactive. Let's move forward to the different parts of our areas available for substitution. So we have R1, R2, R3, R4. For tetracycline, it has the basic hydroxyl and methyl in R2 and R3. Now, if our basic tetracycline is added with chlorine, it will become chlortetracycline. And another is, if our basic tetracycline is added with hydroxyl in the R4, it will become oxytetracycline. Okay? So tetracycline versus demiclocycline, they have different parent or pharmacophore right now because it has no methyl. So it has still the hydroxyl in R2, but it has no methyl, and it has chlorine in R1. So since wala na siyang methyl, that is why it has the name D-me. So that is from the process demethylation. So removal of methyl. Now, I hope you understand now why you have a drug called demeclocycline. And the clo there is obviously from chlorine. Okay, so that's demeclocycline. Now we have methacycline. So it has the different positioning of our functional groups resembling tetracycline. But this time we have in R2 and R4. Another is our doxycycline. So almost the same with our tetracycline, but instead they have the same functional groups na dinagdag sa kanyang structure but on different location. So we have our hydroxyl instead in R2, it's now located in R4. And then our methyl instead in R3, it's now located in our R2. So our tetracycline, our doxycycline has the same nature, okay, but they have different place for substitution lang. Now we have minocycline. So we have here R2 to R4, it has no substitution, while in R1, it will have our dimethylamino substitution, which is also favorable for the improvement of antibacterial property. I hope you all understood now why our tetracyclines are called that way. So you can explain that to your co-pharmacists who are not aware why we call our drugs that way. Now, looking forward to more specific structures. So this is the product already of what I have mentioned a while ago. So this is for the chlortetracycline. This is for the minocycline, the dimethylamino, this one. So eto siya yung, I just screenshot this from our organic medicinal group by Wilson and Gisbos.